What's up YouTube, this is Dennis Panuta for tutorialsEU. In this video you are going to learn about events and multicast delegates in C#. These are two advanced C# concepts that are going to be very important when it comes to advancing your C# skills and also writing more complex applications, as well as understanding what happens under the hood, for example, with a button click event and so forth. So before we start with the video, I would really appreciate if you hit that like button as well as the subscribe button if you haven't subscribed already. And also, if you feel like you are not understanding everything that's going on, maybe you should watch part 1 of the series, so to speak, where we are looking at what delegates are. So if you don't know what delegates are in general, check out our other video first and then come back to this one to understand multicast delegates as well as events. So let's get started. Alright, so in this lecture you will learn about multicast delegates and events. So let's first explore the problem. Imagine we're developing a video game from scratch. Our code is a combination of graphics and audio libraries and the logic for our player. So let's start coding it. Consider the following simple classes. So first of all, we have this rendering class, which at the start of the game we want to enable the rendering engine and start drawing the visuals. So it's going to render and then it's going to start drawing visuals. And also when the game is over, we want to stop our rendering engine. So we have this game over method, which will then stop the rendering engine. So here I'm just using console write line statements. This would of course be a lot more complex code, and this would then actually do something. In our case, we are just trying to understand the concept of multicast delegates as well as events. That's why we're just going to display it via a write line statement on the console. So that's our rendering class. Now let's look at our AudioSystem class. So here in the AudioSystem, we also have the start game method, which will just start the audio system and play some audio. And then we have the game over method, which will basically stop the audio system. And then finally, we have a player, and the player has a player name, and we have this simple constructor where we just set that name based on what was passed to the object when it was created. And here we also have the start game as well as the game over methods. Okay, so this one is going to spawn a player with an ID, and this one is just going to remove the player with that particular ID that we assigned as the player name. Okay, so these are our three classes, and I'm going to keep it rather simple with these. So let's go ahead and go over to our main method. So inside of our main method, we are now going to create objects of those systems. So first of the audio system and then of the rendering engine. So very simple, just simple objects here. And then we also create two players with the IDs. So we have this player 1, which is Steel Cow, and then player 2, which is going to be Dogo Silva. So we need to start our rendering engine, our audio system, and spawn the players by calling the start game method from each of the class. So let's just do that. And I'm going to do it this way. So I'm just going to say AudioSystem.startGame, RenderingEngine.startGame, player 1 and player 2 start game each. And then we just say game is running, press any key to end the game. So what we want to do now is we want to basically end the game once the player has pressed the button. Okay, so it would of course be a lot more complex. Let's say the player presses Alt F4, or in the options menu he closes the game, then the next code would run. So the next code would be of course to call the AudioSystem.GameOver method, the RenderingEngine.GameOver method, as well as player 1 and player 2.GameOver methods. Okay, so let's take care of that. Let's add that in here as well. And by the way, we will need a read statement because otherwise it will directly shut it down. So let me quickly add a read statement here so that we can actually manually press a key to then shut down everything and basically game over. So let's run this real quick and see what's going to happen. So we see the audio system started, audio is playing, the rendering engine started, we now see the visuals, and then the players are spawned. So player 1 and player 2 are spawned. Now the game is running and we can play around with it, and then once we want to finish it, we press a key. So I'm going to press a key and you see the rendering engine stopped, the audio system stopped, and we removed both players. So this was quite an effort to set this up. Now imagine we have to do this with a lot more things, and a couple of things could go wrong, right? So let's say we add more systems, then this becomes a lot more complex. So we can easily forget to call the start game or game over method, or even worse, we could call one of these methods twice, which could cause all kinds of problems and require us to place a lot of protective code. So we would have to really make sure, is this object alive? Does it have called this method, or has it have called it this method, and so forth? Way too complicated. And this is where multicast delegates come in handy. A multicast delegate is a delegate that works as a list where it can store a reference to more than one method. And that's basically it. Okay, this sounds rather complex, but let's build it and then it will probably make more sense. So let's create a static class called Game Event Manager. Quick pause. In this video, you'll learn something about C#. And if you want to learn everything there is to know that you need for the fundamentals and to become a real C# developer, then definitely check out my C# masterclass, in which you're going to learn all of the things you need to know about C#. So you're going to learn how to do the basics, how to use object-oriented programming, how to use WPF in order to create your own user interfaces, how to use databases, how to use LINQ, how to create your own games using Unity, and a lot more. So if you want to become a real C# developer, definitely check out the link in the description below. So, all right, so let's go ahead and create a new class here. And I'm going to call this one Game Event Manager. All right, so this Game Event Manager will now have a delegate. So I'm going to create a new delegate called Game Event. So it's not going to return anything, but it's going to be of type delegate and it's going to be public, so we can use it outside of this class. Okay, so we've seen how delegates in general work, and we're going to use this delegate now to allow us to basically add more than just one event to it. So now let's create the two variables called onGameStart and onGameEnd, and they will be of type GameEvent. So they will be of the type of our delegate. Okay, so this will be a game event delegate, and this will be a game event delegate. So we have these two delegate variables that we can now use. So back to our three classes. Let's add the start game and the game over methods to the onGameStart and onGameOver delegates. Also, there is no need for these methods to be public. So let's go over to the audio system, and now let's make those two methods private, because we don't need to expose them, as we are going to use the constructor of the audio system in order to add or subscribe to the events. So here, the best place to add our methods to the game manager delegates is from within the constructor itself. Okay, that's what we're doing here. And when an object gets created, its methods will automatically be added to the delegates, or in other words, they will subscribe to them. So what is going to happen now is that our start game and our game over method are going to be added to the game event manager onGameStart delegate. And we're using the + sign here in order to say, okay, we want to add this method to that multicast delegate. So basically we're subscribing to it and we're waiting for that event to be triggered, because once that event will be triggered, our method will be called. Okay, so the cool thing is we can now do the same thing with the RenderingEngine class and the player class. So what's important here is I'm using the + sign and not just the equal sign. So I'm not assigning it, and we're going to see later what assigning would mean and what it will do for us. But here we are just adding another method to our event collector, so to speak, or our event manager. Okay, so it's collecting all of those events or methods that it should then execute. So it's a multicast delegate. Now let's do the same thing with our rendering engine. I would like you to do it yourself. So pause the video real quick and try to assign the same code or build up the same code as we have done in the audio system here. Okay, so first of all, I made sure that my methods are going to be private because we don't need to expose them anymore, as that's not necessary. We will never call them outside of this class. That's why it's always a good practice to make them private. What we can call, however, is the constructor, right? So we can create an object of our rendering engine as it is public. So now we can go ahead and add our start game method to the onGame start of our game event manager as well. And the same goes for the game over. So here we're also using plus equals. So we're saying we are subscribing to the onGame start and the onGame over events. So we're basically saying once the onGame start event will be triggered, also call our start game method, please. By our, I mean the rendering engine's start game method. So it will then call this method. And of course, if the game is over, then the game over method will be called. This one here. So that's how we are using the approach. Now, a little challenge for you, do the same thing in the player class, please. Okay, so first of all, I hope you passed. And well, I'm not going to also make sure that these two methods are going to be private because no one is supposed to call the start game and game over method from outside it. But then we already have a constructor here, and I'm just going to use this constructor in order to subscribe the onGame start and onGame over methods to the onGame start events and the onGame over events. Okay, so now in our game event manager, let's add two public static methods to trigger the events from the main method. So here we can then basically execute this event, because now at this point, well, after all of these rendering engines, audio systems, and players are created, once this event is going to be triggered, it will execute something. But we haven't really said what should happen if that happens. So if that event is going to be triggered. So let's create a static method to trigger onGame start. So this method here will first of all check if the onGame start event is not empty, meaning that other methods already subscribe to it, which basically will be the case once we created a rendering engine and this code here is executed, for example, or the audio system is created and this code is executed, or the player is created and this code is executed. Okay, then this statement here will be true. So the onGame start event, game event, will not be empty, which means will not be null, and then this code here will be executed. So what it's going to now do is it's going to say the game has started, and then it will call the onGame start that will trigger all the methods subscribed to this event. So which means that once we call this method here, so this game event, so to speak, once we call it, this method is executed here, this method is executed, as well as this method will be executed. And we're going to see that in a bit as well. Okay, so that is the trigger game start. So this is how we're going to trigger it, and by just calling this method. And you see, we're making it static as we did with the game events themselves, because we don't need to create a game event manager in order to call these methods. So that's what we want to achieve, and that's why we're making them static. So you don't need to create an object in order to call these methods. And then let's create another static method for the onGame over. And I would recommend that you pause the video and you try to build it yourself now really quickly. Okay, so I hope you paused it. It's basically the same thing as we've done here, but now it's going to do it with the onGame over here. So I have this public static void trigger game over method that will trigger the event. And if onGame over isn't null, so if there are methods that subscribe to the event, then this will not be false, and then it will basically be true, which means this code will be executed. And onGame over will be executed, which will then call all of the game over methods, or all of the methods that assigned or subscribed to this game over event, which means this method here, as well as this method, and finally, of course, this method. So now if we are to create a new engine, now we have the rendering engine and the audio engine, let's say we create the third engine, then we don't need to call this stuff manually anymore, but we have set it up, we can set it up directly in the engine where we say we want to subscribe to that event, and the method will automatically be called once we trigger that event. All right. So now let's have a look at our code in the main method, because there is a lot going on here. So now you see all of this code doesn't work anymore, of course, because all of these start game methods, they were public before, but now they are not anymore. So now they are going to be, well, they're private, so they're closed. So now let's go ahead and make sure that we actually trigger this game event. So here we have the game event manager, and we had this trigger game start, because that's what we want to do at this point, right? So once all of the players and audio systems and everything is prepared, we can go ahead and run it. And now we can do the same thing with the game over method down here. So let's trigger the game over event down here. So what will happen now is that it will allow us to make sure that we basically have a very much simpler and cleaner code. So it just makes sure that our code will work flawlessly. So now let's say we add another player to it. We don't have to think about it and call all of these methods, right? Call the start game method, call the game over method, and so forth. We can just go ahead and create this new player, and it will automatically call the methods accordingly. So you see here the game has started, audio system has started, playing audio, rendering engine, drawing visuals, and then spawning player, steel cow, doggo silver, and dragon dog. So now let's press a button, and you can see the game is over, the audio system stopped, the rendering engine stopped, and we remove all of the players. So that is really the power of multicast delegates. Super, super useful, very powerful. We can see that our third object player got the start game and game over methods called automatically, because our objects were notified when both the on-game start and on-game over events got triggered. Now, when using delegates, some things can go wrong. Let's first see some of the mistakes that can cost us hours to fix. Let's say by mistake, we instead of subscribing a method to our event, using the plus equal sign, let's go over to, for example, the players class. Instead of using the plus equal sign, we would have by accident just used the equal sign. So the compiler doesn't say that this is wrong, because this is not wrong. You can also overwrite the existing event with just one method. So what we're doing here is we're saying whatever else was subscribed at this point, we're going to override it. And that's what, well, basically happens here. So we will remove all the methods that referenced in the on-game start and on-game over events, and setting the player, the last player object to be precise, that was created as the only subscriber to all these events. Also, since the on-game start and on-game over are actually public, we can call them directly from anywhere. So let's say we want to call the game event manager on-game start from here, then we can do so as well. So now let's run the code. And you can see spawning player with ID steel cow, dragon silver, dragon dong. The game has started, spawning player with ID dragon dog. Oh, not dragon dong. So yeah, first the event was triggered by our program CS. And then from our last player, which was our dragon dog, it also called the on-game start once again. Okay, so that is basically what happened here. So we really need to be careful here. That is something that can be super difficult to fix. So now we can't mark our events as private, because we need them to be public to subscribe to them in our class constructors. So now we've been using the name event when talking about delegates, because our delegates were literally behaving like events. But in fact, there is a special type of delegates called events, and that is made to prevent these kind of mistakes. All right, so now there is a beautiful keyword that helps us to prevent this error, and that is the event keyword. Because basically this delegate that we created in our game event manager here, this public static game event, is an event. So we could have just used this event keyword in here. And this would prevent us from even making this mistake, because now you see that it's not happy about what we've done here. So we can override a delegate, but when it comes to events, we can only subscribe to them. And we cannot just call this event directly. It will be triggered from the game event manager directly. So we can no longer call the event directly, since onGameStart is now an event, and we will be only allowed to call it from within the class where it was created. And also, it is forcing us to treat it like a list. So having an event on the left side of the equal sign is not allowed. So something like this, as we've seen, is not allowed. All right. And now if we run the app again, you will see that it works flawlessly. Let me run the code, and it went perfectly well. So this was quite a condensed example and a rather simple one, because we looked into delegates, multicast delegates, and events in one video. But I hope that this video made clear what advantages you have when it comes to working with delegates and events. And the cool thing is, you have now seen how to create your very own delegates as well as your own events, because we're going to see a bunch of more events later on when it comes to using the UI. For example, when you're clicking on something, then an event is triggered, and multiple things can subscribe, multiple methods can subscribe to that event that was triggered and then be executed once, for example, the button is clicked or any key on the keyboard is clicked. All right, so now let's sum it up really quickly. An event is a restricted form of a delegate, forced to behave like a list. So we can only add or remove methods from it. So we can subscribe or unsubscribe from it using the plus, equal, or the minus equal sign, but not the equal sign. A delegate allows a direct assignment via myDelegate equals myMethod. Doing so replaces whatever other methods had been added to it before. So be careful here. Also, events can only be invoked by the class that defines them. From outside their class, you can only register and unregister methods to them. Thanks a lot for watching this video. I hope you enjoyed it. Now you know how events and multicast delegates work, and you can use it for your own projects. And now, if you haven't liked the video already, it really helps us out if you do that now, and also subscribe so that you don't miss out on all of our great C# content, as well as Unity content if you're interested in game development or even app development with Android. So see you in the next video, hopefully. Have a nice day.